This is the Amp Hour Podcast. Released February 10th, 2019. Episode 429. An interview with Charles Alexanian. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Charles Alexanian of Alextronics Controls.
Hey, Charles, how you doing?
Doing pretty good. Wonderful Saturday morning.
Yeah, nice and bright and sunny out here at least. Freezing cold, but sunny. And
well, I'm looking at a multi-hour sojourn into the snow a little later on today to go check on some things.
yeah, you guys are getting pounded out on the West Coast. So you're like near Fresno, is that right?
Yeah, Fresno. We actually very rarely get snow here, but not an hour away up in the mountains. It's a full-fledged winter storm going on up there.
Oh, wow. That's crazy. So let's hear some of your history. I mean, I know, you and I met because of podcasting stuff. You started kind of helping me with some suggestions and, we got to know each other just through correspondence and stuff. But over time, I've followed your work and, you write for Hackaday as well. And people may have seen some of your talks and stuff. So maybe we could start kind of back where you got started in electronics and then work our way forwards.
Yeah, well, I've kind of drunken stumbled my way through an interesting path in electronics career. Started out product of a family business. My father was a QC engineer in the 70s. Originally started out actually with the military. He did the initial field evaluation of the first headset night scope out at Hunter Liggett Reservation in the late 60s, early 70s. So,
oh, wow. So is that like something that instead of having it like on a gun, it's actually like you're wearing like a night vision goggle kind of thing, or what?
Yeah, before that they'd mount them on tanks and helicopters and things like that, and that was the first one that they actually, we would recognize today as a night scope. He would, during Desert Storm, he'd point at the TV and say, "Look at that! I was doing that 25 years ago."
Oh, wow. That's crazy.
So, anyways, he through, of course, all things in life, getting married and physical location determine a lot of what you do. Moved from the Bay Area down here to Fresno, and all the engineering work here was irrigation related. So he worked for a company at that time, Buckner, who made sprinklers and things like that, valves, and they also had a control department. And this was during the very, very first years of digital controls. He can't exactly remember, but it may have been 8008 era stuff.
That would have been really expensive too to add that to a irrigation controller, right?
Oh yeah, but they were back in those days. That was a big business, the golf courses and resorts and things like that. So lots of money was being put into that sort of thing. And the company wound up getting bought by Johns Manville, who makes, at that time, asbestos and insulation and things like that.
That's a good business.
Yeah.
Right.
The controller was so difficult to program, they sent you a prize if you successfully navigated how to program the thing.
Oh, wow.
So anyways, that was kind of doomed to failure, I guess you could say. And he started developing a simple mechatronic controller, which versions of it still actually exist in production. But the company went through some changes. They got bought out, this and that. And at one point they came along and had to do every department has to cut back, and we are the only one in your department, so see you later. So, yeah, they cut off their own quality control. So he left and started his own business doing a similar product. And actually for many years, we sold that product back to them. And that was quite successful. And then I came along, and a real business of it had to be made.
I was born with a soldering iron in my hand because, well, that was the work to be done.
Yes, that's it. That was exactly it. I remember being a young child, pre-kindergarten, assembling our clock dials, which were plastic dials that had the days of the week and the hours of the day on them, and we would push in little plastic pins, which you would push in and turn like on one of those old style lamp timers.
Yeah.
Yeah, that was my first job, was assembling those things, and very quickly
Wow.
moved to soldering and all that sort of stuff. So
So actually, before we keep going with the history too, can you mention, so like Alextronics is a irrigation kind of based company, but could you
yes.
explain like what the general idea of the company is as well?
Well, our primary focus has been OEM manufacturing of timers and controls for other companies, because we realized a lot of the companies out there had experience making sprinklers, valves, filters, etc. But not a lot of them wanted to go set up their own electronics department to make custom controls. And remember, the
Right.
late
Yep.
70s, early 80s, and all that, that was a big, hairy deal. Not like today where anybody can go, in their garage, start bootstrap a product, and off they
Sure, sure,
go.
sure. Right. If you're making like custom PCBs, you're ordering parts from random
Exactly.
ass distribution channels, stuff like that. Parts are really expensive, like you mentioned.
Oh, back then especially, yeah. I see some of the prices on things back then, and my eyes fall out of my head.
Yeah,
But
yeah.
anyways, we eventually focused on a few specific markets. We used to do a lot of load sharing, energy sharing things for large pumps. That's kind of gone away now in the modern digital age, where they just have industrial PLCs out in the field doing that. But filtration of water is the number one use for us in agriculture at this time. We did sprinkler timers and controls and things like that, but we divested that part of our company to well, I could say it's public, to Hunter Industries, and they're doing quite well with it. They've got a good line of products. They've got good people down there. So we got out of that retail end of it. It just didn't fit our future growth plans.
Right. And filtering is necessary just because of the sprinkler heads and stuff like that, right? So like if you have
Yes,
impurities in the water, you need to be able to make sure that you're not cranking that through a nozzle head or
yes.
something like that.
Exactly. The traditional wasteful way of irrigating is flood irrigation, which still exists for some types of crops. It is the most efficient for some types of crops. But generally, low flow, efficient irrigations, drip, micro sprinkler, subsurface, and that requires a clean source of water, typically filtered to 220 micron or so, sometimes more, sometimes less, and that requires automation of the filters and the other systems to provide that. And we sell our product primarily OEM to other manufacturers, filter manufacturers. But as time went on, and we already had a good reputation in the field from our history of other products. Most of our OEMs found it advantageous to just simply leave our name on the product. And as part of our service for them, we handle the direct-to-consumer service on those products, phone calls, etc. And through our dealer network, the other OEMs don't even need to get involved with returns and repairs. So that actually is our biggest service that we can provide.
Yeah, that's nice. I mean, it's a tougher business, I think, if you have to support stuff directly, but you get the benefits of the brand stuff you're talking about.
Yeah, there's no reason why our product shouldn't go 15 years if they keep the box shut, keep the bugs and pests out. No reason why they shouldn't get 15 years trouble free out of our products.
That's great. So okay, so that's good. That's like a good overview of the actual products and stuff. So back
Mm-hmm.
to soldering as a toddler.
Yes, we being a family business, we've never had more than a couple of employees at any given time. So family had to be there. My grandmother was our first bookkeeper. My mom did the wire
Mm.
harnesses. Dad did testing and some assembling and shipping and invoicing. And like all true small family businesses, we did nothing but lose money for the first many years.
Yeah, I always wonder about. Yeah, I just wonder like how that's possible too. Was it like borrowing and like then like cash
Borrowing,
flow
yes.
wise? Yeah.
Borrowing,
Okay.
yes. And then customers realizing you're a small company and realizing they can push you around a little bit.
Yeah.
And just you have to get a name and really learn what you're doing. I always laugh when I see these reality, quote unquote, reality shows, where it's a family business and they have to cook drama. And I'm thinking to myself, well, that's how I know that's not a real business. You don't have to cook anything, just wait for the phone to ring.
Right. Exactly. Right. Who's actually getting this order out the door today? Right.
Exactly. Yeah. Yeah. It started in 77. By 1987, we had stopped losing money. And then by about 1990, they actually made a little bit of money. And then we've we've remained profitable, although it's not an explosive growth industry. We've remained profitable ever since.
That's good. I think the interesting thing too is that, and like I've heard this from other people. Actually, when Chris Denny of Worthington was on here, he talked about, I think it was 70s era as well, of like the people who started Worthington Assembly, whatever they called it before that. It was something like Moronics or something like that. It was, but it was just like that era of just like, oh, well, we'll just start a manufacturing business. Whereas I think about that now in like capital investment and doing hand assembly and doing all this. Like I personally, I would never think to do that. I mean,
no, same here.
Did you have any insight into that? Was your folks like, well, it was just a thing to do, or what was it?
Well, yeah, it was all they knew, and Dad had developed that product that he was more or less able to walk with. And that was that. He was stuck here in Fresno, and the only other thing that my mom's family had done is run a grocery store, and they vowed they would never ever get into retail ever again. So it was either go look for a job. There was one job in between, though, that he had. It was a company called Lightronics. He used to manufacture calculators and digital watches and things like that. And that could be a whole show into itself. You'd be better off interviewing him about that on all the pitfalls of 70s large volume consumer electronics.
Right.
But,
well,
that didn't last
I think
long.
we're gonna get into it later too. But like the idea of like these kind of remote manufacturing, and like I said, we'll talk about it later of like the challenges with it. But just the idea of that, it does sound like it's it's either you make your own job in this case. And and I guess the same thing with Worthington was like it was like kind of in the middle of nowhere, but it was just this thing that to get the job done. So from that perspective, it's interesting. We wanted to build this product, we thought there was a market for it, so we built it.
Well, my friend Don Schmidt, who in himself is an amazing story, told me one time about this very subject. He says they put the power plant where the coal is, they put the glass plant where the sand is.
True.
What do you expect was going to happen?
Right. Yeah, no, that's a good point. Or even more to the point, I think they put it near where the power is these days. I mean, I guess the coal.
Still coal. We're still a dirty coal society.
Yeah.
So that's the one thing we all should be focusing on, but no one seems to want to. So
right. So as you were growing up doing this stuff, I mean, how did that impact your electronics learning and stuff too? I mean, it sounds like it was pretty hands-on from the beginning.
Yeah, the actual assembly part of it and all that just came from here. Here's a bench, sit, put this together. So I learned how to read schematics. I don't even remember a time not being able to read schematics and do basic calculations for things.
Yeah.
As far as the actual, in earnest electronics learning didn't come until a few years later. Of course, the requisite, whatever in one Radio Shack kits, of course, because
of course.
Dad got tired of me, pulling parts out of inventory. 6-year-old kid doesn't realize those half-cent resistors do add up after a while.
Right. We're not making it. We're not making the count again. This is not good.
Exactly. Yeah, inventory's off. What's going on? Oh, Charles built a radio. Oh, okay.
Yeah, right.
So there was that. Then as I got a little bit older and was able to actually really learn, got a few basic books and always had the benefit of having experienced assemblers and a couple of experienced engineers floating about to ask the basic questions. So.
Well, then did that end up transitioning to like when is it like, hey, I built or I designed this thing? Like when does it transition to that point? Is it much later?
Well, I mean, as far as having input on designs or actually designing my own products, or both?
I'd say, both really. I mean, because I'm guessing you probably did build some of your own stuff, but then like, when is it? Oh, yeah. Because I think there is this kind of like mental piece of like, it's tied up in family and there's, everybody has a role within it. But then if it shifts and it's like, hey, I'm now moving from helping with assembly to building this thing. Mm-hmm. Or designing this thing, I assume that kind of changes things too.
Yeah, that took a number of years. I mean, my father stopped being current on things in the 80s. He never made the jump out of mechatronics to full digital. So of course, as a founder of a company, you have to realize the point at which you're no longer effective to drive the technological future of the company. You're you're either, an executive, you're going to run the business
Right.
end of it.
Yeah. Got to sell
Or
stuff. Got to hobnob, that kind of thing. Right.
yeah. I mean, somebody has to, be able, you kind of have to have the clarity of mind of not worrying about, doing development, to be able to move forward, especially when you've got several employees for you and a number, many customers. So
Right.
that
Yep.
decision was made, and we brought in a outside engineer who's actually still with us. He'll probably be with us until he decides to stop working, and we kind of went from there. We would not farm out the designs, but we would hire his time, and he would do our design work for us.
Oh, yeah. Right.
We'd give him the input. The first product I recall directly having some input on was in about 1992. We were redesigning one of our popular products, and we wanted to figure out the feature set and things like that. And that was the first one that I can remember really having an input on. Here's how this thing should function. Here's how the display should lay out. Here's how the knob should be. Blah blah blah. And that was the first step.
Well, I mean, that sounds like a pretty good chunk of time there, but it's also like a lot of hands-on time and helping out with the manufacturing piece. And speaking of the manufacturing piece, I mean, this was all through-hole stuff to start with, right?
Yeah, correct. Yeah, we're still some of our lines are still completely through hole.
Really? Okay. And so how does that impact like assembly processes and stuff like that? I mean, do you guys have? I guess we'll get into pick and place stuff too, because you and I have kind of gone back and forth on Neoden things, but like, has it ever transitioned? Do you ever look at going outsourced or of like doing SMT assembly?
We historically have been so seasonal that we've had to use outside vendors for to help smooth over the supply difficulties. Our current place, I don't mind
Right.
blowing them up, but is Tellarite up in Fremont across from Tesla, and they're great at doing 100 boards at a time sort of thing, and they're good about remembering who you are. So you do a few batches one year, you wait a year and a half and do another few batches. They don't go, who are you again?
Right. Let me just dig into the files, right?
Yeah, exactly. Yeah. So we're not afraid of doing that. As a matter of fact, I'm right now kitting up to do a few hundred panels out with them. So that was this week's activity, was making sure we had enough inventory, which with Chinese New Year,
Yeah, it's a fun time. Time. Definitely gotten caught a couple times myself, but oh well.
Yeah. Anyways, so I went through a period, family business, fear and doubt are always the primary motivating factors. So the thought is, what if this thing doesn't happen? What if Motorola comes in next week with their own product line at half the price and all this sort of stuff and dump a bunch of advertising money behind it? What if? Well, my parents kind of what if myself right into thinking maybe this is not a viable future at a certain point. Maybe I should look into other things. It all turned out to be nonsense, but
No, I think that's really fair though. I've heard that a lot of like people who are in family businesses too, like, maybe you get a second generation who are interested in doing it, but by third generation, usually, either the business has taken on a life of its own, or there's just less interest in it because it's such a big part of the family.
Well, it dilutes. You figure, all of a sudden you're serving the machine rather than running the machine. And that's a fear that I talk to other people in similar positions of the same thing. So I spent my teens thinking, well, maybe I should go figure something else out. And of course, everyone being dumb, and like every good band geek decides to throw away their original instrument and pick up the guitar. So, and of course,
I went through that phase.
Yeah. Oh gosh, I wish I could go back in time and learn how to play the piano properly. Oh gosh,
Yeah.
Anyways, so that of course leads you down the standard path of of all the effects pedals. Remember, this is the 90s, so effects pedals are king. And I could build that. I got the parts for that. And all of a sudden, you think you can make something out of it, which is usually pretty bogus. But I went down that path. As just something, a diversion, something to do. And while I still had some time in my life to not really worry about the future, I heavily investigated that market.
Mm-hmm.
I opened up at a certain point a repair business because there's not many other repair businesses in Fresno. doing musical instrument electronics repair.
Okay, so like amps and pedals and
Yep.
all that stuff. Yep.
Yep. At a certain point, I was actually manufacturing replacement parts for amplifiers. This was in the beginning of the swing where everyone was coming out with their own Fender brand amplifier kits and things like that. And our metal manufacturer at that point came and said, "We're looking at expanding our business into more things. We want to take on more work." So I went ahead and designed up some duplicate chassis of some of those products. And at that point, somebody I was buying from was under license from them to sell reproduction parts. So we went ahead and manufactured those for them, and then
reproduction carts or parts? Sorry, I missed that
parts.
word. Parts. Okay. All right. So
chassis,
this is all in the amp business, like how everything's chassis based. There's like a big transformer. There's a bunch of tubes on board, that kind of thing. A lot of surface mount, or a lot of through hole soldering, point to point.
Yeah, through hole and then point to point with vulcanized fiber boards and eyelets and things like that.
Yeah,
50/60s technology.
And it's amazing that it's still such a thing too. Like it never ceases to amaze me that the amp stuff is like, I saw an article, I think because Google like watches my articles, and I've been looking at tube stuff at one point. It was like, are circuit boards or hand wired amps better? It was like, what?
No.
It's just,
if you're going to go in and cut the thing apart and modify it, that's a different story, because, obviously unsoldering a wire from an eyelet, you can do that many, many times before it falls apart. On the low cost, I've got a story to tell about one of the amp manufacturers that shall remain nameless. We shared a PC board vendor at one point, and that guy came into our shop one day to talk to us, and he was upset about something, and he was outside on his phone, and he says, they want me to go to 1/2 ounce copper. Single-sided, unplated 1/2 ounce copper, and
wow.
he in that moment decided he wasn't going to take their business anymore. So that gives you a little insight into that world of how those the $69 or $99 thing you see at Guitar Center, how they go about building that stuff.
Right. And if people don't know, standard is 1 ounce. If you go to like a JLC or an all PCB or a Bosch Park, whatever, you get standard 1 ounce copper. 1/2 ounce is going to be really, really thin. 2 ounce if you're doing thicker stuff, right? And it's just going to give you worse connectivity, worse thermal performance, stuff like that. So they were really cheaping out, huh?
As much as, they were squeezing nickels,
that's crazy.
So, and for no reason too. I once heard a story from a Ford executive who said, when we were selling Mustangs and Falcons and all that stuff, which were all essentially the same car, somebody said, well, why didn't you, bonderize or corrosion protect these bodies? All it is $1 to dip the parts, at that point.
Sure.
And he says, well, we sold 245,000 of them that year. That was a lot of money back then.
Yeah,
that was like 10 or 20 employees. You go to the board and tell them, we can either do this thing or lay off 20 employees and see what they say.
Right. And that might mean that you sell fewer cars in the future too, because now they're not rusting out. It's like, it's a consumption business effectively. So yeah, it's a hard sell.
Yeah. Automobile, aside from the light bulb, the automobile was the original big consumption business of every 5 years you buy another one and you want to. So
right.
Anyways.
Right.
I'll try to pick it up here a bit.
I'm curious about the repair shop thing too, because I think that's a common thread in a lot. Personally, I worked in repair at one point. That was like, I hated it first off, but I think that's such an important piece for people getting started in electronics, because you see, obviously you had stuff before it, but you see the same problems over and again. You get that, you get those 10,000 hours, like what's his name always talks about, Malcolm Gladwell. And other, the researcher that he sold that from.
Exactly.
But yeah, it's like you see those patterns over and over again. So I'm curious about like that business and how that ended up working out for you.
If you want to learn electronics, pick up board level repair. You will learn electronics whether you want to or not.
right. And
Also,
soldering,
too, you
soldering
develop.
really well.
Oh yeah, yeah. You determine, especially in surface mount, every form of drag soldering. You can always tell the engineer that or the technician who does surface mount repair, because he has his little cup of all of his various fluxes
Yeah,
ready
right,
to
right,
go
right.
at any given time.
Yep. Yeah.
Oh, this goes with that one. This goes with that one. This works for that. And you get, you hold the iron this way and you blow on it to get that
Right,
pin to flow.
right, right. Exactly. Wiggle your ears. If you wiggle your ears while
Yeah.
you do it, it really works.
Tongue angle,
Yeah,
quite
tongue
critical,
angle.
quite
Yep,
critical.
yep, yep.
Yeah, kids, if you want to learn, start doing repairs. You'll learn real fast, and you also learn the limit of the components and what they can actually do. And I like to say you get that you can tell by smell. When you come up on a product, you can kind of sniff out before you even know what's going on. Get a general idea. Yes, I know it's profiling, but it actually does work out quite well. I just did it the other day. Someone brought me, a friend traded me out an amplifier, and he's an excellent engineer, and he told me, no, it works great, it's perfect. I brought it, had it sitting in my living room, and I could smell something wasn't quite right, and opened it up, and sure enough, a screen resistor, look that up, kids, had been partially burned. And sure enough, I put it on the scope, put the signal into it, and could see it was distorted waveform, and sent him a picture of it and a picture of the board, and he said, "Oh, geez, I should know better than that."
Nice, nice.
Yeah.
Well, it sounds like another thing that you got out of this is, from the repair side, at least, it sounds like, you see, not only do you see a lot of equipment, but you get in contact with a lot of people, right? And you're kind of handling especially in the music industry, you're handling their babies effectively, because that's how they have their signature sound, blah, 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 blah. But it sounds like, you know some interesting people from this, it sounds like, given the tube stuff and other people.
Well, that led down another couple of paths that studios in town would start having me do stuff. I'd always played musical instruments and fiddled around with friends and bands and things like that. You just, one of the biggest things, of course, was trying to find repair parts, which was becoming increasingly difficult. We didn't have the internet really at that point. It wasn't like it is now.
Yeah. What is the timeline of this repair business?
This is late '90s and into early 2000s.
So
you try
eBay
finding
maybe,
parts.
but maybe not. Like that. Kind of thing.
It wasn't even eBay yet. It was Ubid.
Yeah, I don't remember that one.
So, that's look that. Okay, kids, look that one up. Ubid. Oh geez, that's a whole different thing. So finding parts was an adventure. It was at the point where you just flip open the Thomas register. Oh, that's another one to look up, kids. The Thomas register.
Thomas is still around, actually. They're still ThomasNet is still around. Yeah.
Oh wow, that's interesting. Yeah. It's probably all online, I would imagine. Picture definitely 20 telephone books lined up, holding your bench down. So this was a magical thing where you would look up manufacturers of various items. I need sockets, so look up the manufacturers of sockets. Okay, there's 20 manufacturers of sockets. You go down the list, calling each one to see who's still in business.
Yeah, right. That's what's crazy about it.
Yeah,
you could still find Thomas. I actually went to my central library last time I was there, and I actually, they still have them, but it's like, a Thomas register from like the 1890s, or they have 1920s,
Wow.
It's old. It's an old. I don't know if it's quite that old, but there are some old versions that they had in there.
It would be great to look through some of those, particularly war era ones. I really enjoy. One of my hobbies is looking through war era catalogs and things like that at the electronics mindset. They were far more advanced back then than we give them credit for.
I don't know if come on, really? Like what kind of, first off, what kind of catalogs were you looking through, and what kind of stuff makes them more advanced? Because it seemed like it was all, it's all tube stuff and early Germanium transistors into the 50s, 60s, right?
Yeah, but for example, the precision of things done back then was amazing.
Oh, okay, sure.
Accuracies, tolerances, and precisions were amazing back for what they had to work with. They don't even have a proper, I mean, this was in the days of VTVMs where plus or minus 5% was considered great.
Yeah.
If you look up what they used to use for electronic standards back then, some of the wet mercury cells and things like that, and lithium cells,
Hmm.
it's really an art form. It's really a dark art, a lot of that stuff. But what
Yeah.
they were able to accomplish was quite amazing. Man, they made a nuclear weapon with
Right.
little
Right.
more than stuff today would be only usable as movie props.
Right. Right. Right.
Anyway, so as Todd Black says, that's the stuff that put us on the moon, and that makes you think a little bit. So,
Yeah.
anyways, so getting parts was always an issue, and that led me two different directions. First, the quality of speakers at that time, and I've been out of it now. I'd imagine things have gotten better, but the quality of speakers being made by the major manufacturers at that time was awful. And I had encountered a gentleman by the name of Don Schmidt out of the Chicago area who was a part sourcer. He had partnerships with factories in China and factories around the United States for parts for speakers. And I eventually, after realizing that the guy was, the legitimate real deal.
Sure. Right. He's not selling you sawdust in a box, right?
Yeah. After the first few times that he'd say, "Hold on, I'll have someone contact you," and I'm talking to the former president of this and that company, Rolla, Oxford, Jensen, Utah, all those companies, that I realized, oh, he is the, and that gentleman is someone you should probably interview because he has an amazing history, and he's right there local in your area. He's in Naperville. Cool. He can getting off the train in his town's like stepping off into Pleasantville. It's remarkable, Yeah. But eventually he was able to get me sourced with an American manufacturer to manufacture good quality 10-inch Alnico magnet speakers for me. And I had a few customers lined up, some people in the aficionado realm would recognize. We went ahead. I had the products made, purchased them, labeled them, brought them in, tested them, and turned around to those people who were interested in them and said, here they are at a reasonable price, ready to go. And all of them said in unison, that's great, we'll let you know. So that was lesson number 2 in how not to do things. Make sure you have their money first before you go invest your own money.
Yeah, that's a good one. Yep.
Yeah. So, that stung a little bit. So that and a few other experiences and just the general influx of import cheap stuff into that market, I decided to leave the repair business behind. Another friend of mine was reopening his business. So I just put a message on my phone. If you need repairs, everything's now gone over to this shop. Thank you very much. And that was it. So once again, I kind of needed to, see if there was something else I wanted to do. I did keep customers, though, from that era. There was certain studios that I was doing work for that I liked the people there. And I decided that would be kind of a fun thing to keep my finger in that business. And that, I'll get to that a little later. I decided at that point I wanted to, it was a college time, and I already knew this electronics thing pretty well, and I decided that if I ever wanted to pursue a career in that, just what I knew already would be good enough. So I decided to expand a little bit and decided to try to go get my electrical contracting license. So I went to school for that and took the programs, took the NEC courses. And just about the time that I was about to go, I would need to go get another few years work experience at another company. And many of our customers are actually electrical contractors. So I had talked to a few of them to see if I could just go along, and work with them. I'd essentially be I'd be installing my own products essentially in the field, which would be convenient. They wouldn't need to train me, and I'd get the work experience. But at that point, our business started taking off, and I made the decision that I would need to stay there full time, and I've been there ever since. It's now been 22 years I've had the same bench.
Wow, nice. That is that's a level of cruft, I'm sure that is unrivaled by some.
Is cantankerism a word? Sometimes the joke I always say is, I'm going to be there the rest of my life. One day the other employees are just going to flush me down the toilet when I die, and no one will notice.
Goldfish style.
Goldfish style. I'll get the goldfish Viking funeral. Yeah,
that's right. Yep.
I'm fine with that.
That's great. So then, like, I thought you had said that the sourcing stuff went in two directions. I figured that was going to go towards the tube stuff that you started doing. Where did that come into it?
Well, one of those times searching down the Thomas Register, looking for tube distributors, because at that point, most tubes coming into the country were controlled by two different import sources. There was New Sensor, Mike Matthews in New York, who's still around, and then Groove Tubes, basically, who was bringing stuff into L.A., and I met with the Groove Tubes people and wasn't very impressed with their level of experience and knowledge. And then met with the people at New Sensor, and they made no pretense about it. We bring stuff in cheap from Russia. We pretest them to make sure you don't get a dud. And we're not going to go over there and tell them how to fix their tubes or anything. So we just sell them at a price where you buy two. If you need one to work, buy two and test them. And if you get a bad one, send it back. So okay, I understand. At least they were honest. Yeah. So I would buy from them, but still, at that point, there was still a lot of old stock sitting around on distributors' shelves. And I actually spent quite a bit of time going around buying up old television distributors and things like that, stocks of old tubes, sorting through, getting rid of the ones that no one needs and keeping the good ones. And back to the Thomas Register, started going down tube distributors and manufacturers who were still in business. And most of them, of course, were just, didn't
connect the phone, right? The phone was like the unconnected signal.
Yeah, I wish I had that. You can probably find that tone somewhere on the internet, but it's a particular tone. Yeah.
There's also do do do.
That's the one.
We're sorry.
That's the one.
This number is no longer connected. Yeah,
exactly. That's the one. And I got one of them. Someone actually picked up the phone. And it was my now friend, Miss Ronnie Ellsbury, down in Oceanside, California, at a company called MU Incorporated. And she proceeded to explain to me that they really were a second source for the government for very specific particular things, mostly high voltage things. But she was located in California. And I talked to her about what I was looking for, and she says, "Yes, that's what everyone's looking for. We've entertained some ideas of doing this stuff, but we've determined that most of the people in that business we don't want to do business with."
Right. Especially if you're coming from the government side, where people are paying lots of boku bucks for a tube versus someone trying to replace something on their fender. I'm guessing it's pretty stark difference.
At that time, the cheapest product they were selling was a 2C53, and it was about $140. So that just gives you an idea of what sort of market they were in. That would say high voltage pass triode used in X-ray regulators, supplies, and X-ray machines and things like that. So
wait, can we take a quick break just for? What are tubes? In case people don't know what they are. So we say tubes, right? We're talking about vacuum tubes, but could you give us a quick look at what that is and how they're still used today?
Yes. So to get electrons to flow in a controlled manner, either for rectification or for amplification, you need something that we, of course, refer to as a semiconductor. This can be a solid material, or it can be simply by application of energy in the form of heat to a metal, the liberation of electrons, which can then traverse a vacuum in space. The earliest attempts were, of course, crystal detectors, which are solid state, which work on forming a junction of which electrons can go one direction but not the other direction. The technology to get that to work in a controlled fashion just simply wasn't available at that time. But the light bulb industry was. And it was determined that in light bulbs, you could get electrons to cross the void by from one heated piece of metal to a positive potential collector. And that was, of course, referred to as the Edison effect. Of course, Edison didn't find it. One of his people did, but it still got called the Edison effect. Anyways,
Yep.
look that one up, kids. And then that sat for about 10 to 15 years unused until it was determined that it could be used as a detector by a number of different people. And the first one to really capitalize on it was DeForest, who's kind of known as the father of the vacuum tube, and determined that could be used as a detector of radio signals. Then, in an effort to attempt to increase the sensitivity of that detector, they added an additional element between the hot body of metal and the collector, which they referred to as the grid, which they would vary potential on, and the idea was to attempt to get the rectification point of that down lower to zero to be a more sensitive detector, and that did work. And that was actually the first application of those tubes. But they also discovered that as the quality of vacuum got better, that the tube would actually act as a first switch, and then later as a linear amplifier. And that's really the birth of modern electronics, is when they determined they could actually make a linear amplifier.
Right.
And then off to the races, right up to what we have today.
Well, yeah, I mean, it got supplanted eventually as the switch stuff got supplanted, and then eventually even the transistor stuff got supplanted. But I think I think that's a really good point, though, about those four things you were talking. Well, I guess you're talking about three things, right? You're talking about rectification, and then linear amplification, and then switching. Those are probably the big ones.
Yes.
That all got taken. In solid state, definitely took over all of them in the majority cases. But what you're talking about, and what Ronnie was working on, was in some cases you just can't really get away from, because of the spaces that are involved and everything like that. The physical space, you just needed to have more physical separation that a vacuum tube offers.
Yeah. Well, what I was referring to is with the exception of ZVS devices, everything is either still a rectifier, a switch, or a linear amplifier. Down to the smallest geometry solid state device today, it still falls under one of those three categories. Less ZVS devices, of course, which follow a little different principle. Yes, in certain applications, high voltage, high power dissipation, and need of linearity, still in some instances, tubes are still the best thing. And high power, high frequency generation, the solid state devices, the geometries involved are just very difficult to get the physical heat out of the device and have enough physical separation that the voltages don't arc over, especially at RF.
Yeah. So what are some of these things that, like, so you said X-ray, but then also, like, is it like AM towers, FM towers? I guess, like AM, FM towers, or like a TV transmission obviously is kind of dead.
Well, don't forget, most TV transmissions are still operating around a lot of it's still in the VHF, UHF range.
That's true. I guess it's just digital mode now instead of just pure analog.
Yeah. Well, what really cemented the viability of tubes into the future was radar and microwave. The reflex klystron, cavity magnetron, and all the various versions of that. There's bunch, pulse, and wave modulated traveling wave tubes. All of these are still extensions of the same basic vacuum tube information technology. And if you want to do further research on that, and remember, most of our telecommunications still work off of traveling wave tubes and things of that nature, especially satellite communication. Look up the company Varian, the Varian brothers. They're the ones who really... England gets credit for the magnetron for the radar, but they really don't deserve it. It was really a gentleman from the Netherlands, and then the Varian brothers independently developed their own system, which they hoped for.
The klystron stuff, is that right?
Yes, that's part of that family. All of those are all part of a similar family, and we're still using them today. Varian is still in business as L3 Communications. Perkin-Elmer, and all of those big, scary, huge companies still manufacture the things by the thousands.
Yeah. I think Varian's involved in, I think semiconductor stuff too. I think they do some of the ion implantation
Yes.
stuff as well.
Yes, they manufacture ion implantation devices, and I just recently learned a lot of them still use old pass regulator tubes, because I
Oh.
got a request from somebody, some fab somewhere in Asia, wound up in my email box saying, we need these tubes and we need them now. So they're still being used in modern processes there, because a lot of those machines have simply never been replaced.
Right.
How do you they're targeting a beam.
Right. It's effectively a big CRT television, but you basically, instead of electrons, you're like, how about boron? How about phosphorus?
Yep. That's exactly it. Yep.
Yeah.
So how do you steer a 40,000 volt beam with a 100,000 volt tube? So
right.
So
okay, so let's go back. Let's go to Ronnie again. So basically, you called up Ronnie. You said, "Hey, did you like go and learn from her? What would happen there?"
Well, we talked, and she actually said, "I'm actually taking a trip with my husband. We're coming up by you. Mind if we stop in and visit and talk with you?" And at first, she said, "I just want to talk to you and explain what the real story is." And she did. And she explained to me the various processes, and mostly the reason why we don't do things in the United States, not for any environmental reasons or anything like that. It essentially boils down to labor and materials availability. A lot of the stuff was either hand assembled or a large degree of automation, which is very expensive to implement. One custom machine tool, maybe $100,000. How many of them do you have to sell to re-advertise that cost over to make money? A lot. And also, you can't pick up the phone and call 10 different people and say, I need glass bulbs of this size. I need metal parts of this size and this specification. I need them next week, and I need them cheap.
Right.
It just doesn't exist anymore. The market has moved on. And these were all the roadblocks, because as most people in the music business will tell you, they're very cheap. No one wants to spend $100 for a tube to shove in an amplifier they're trying to retail for $300.
Right, exactly.
So that really was the end of it. A lot of those guys spent many years to try to sell their import stuff, saying we can't environmentally do it here. That's nothing. That's completely bogus. All of the things that they purport would happen would lead to bad quality tubes. It does have to be done nearly under clean room cleanliness. Not to that extent, but chemically must be done to near clean room cleanliness. And all of the things that get accused of having mercury and all that stuff would actually lead to bad tubes. So
got it. Yeah.
But she came up, we visited, and I realized I like these people. And when I would go down to San Diego, I'd go visit, and I would take time to help them calibrate machinery, test sets, little engineering things. And she would show me, the processes and things of that nature. Her husband passed away. He got ill and passed away, and so she was left alone with only her uncle, who at that time was in his late 80s, and one part-time employee to help her run the company. So I stepped up the amount of times I would go down. I'd try to go down there every month or every other month and spend a weekend and help out.
Yeah,
and that went on for many years, until 2 years ago. She actually told the government everything was last time by as of about 2002, 2003.
Right. Which, of course, means that they're like, we'll take 20 years worth, please.
well, you would think that, but there's laws that prevent them from doing that. Contrary to popular belief, where government spending is just this tap of money that flows to large companies. Well, maybe it does to the large companies, but to small companies, they will do everything they can to string things out, not pay you, and do whatever they can to make life difficult. And they'll try to push you around a little bit. She had a good working relationship with her buyers for many, many years. They understood what she did. But those people had retired and the new wave of people came in. She just didn't have the time or desire to try to bring them up to speed with how things were, and simply decided to close up. As of 2 years ago, she made the decision that she was going to close the shop. And she asked me to start finding potential buyers for her. I at that point started buying bits and pieces off of her that I would know I would need to bring home to set up my own operation, and did that for over the course of about a year. And even before that, I had started experimenting here at home with things because I didn't want to have to drive to San Diego every time I wanted to try something out.
Right.
So about 10, 15 years ago, I started making my own little rudimentary tubes. Never really advertised it to anybody, just something to do as a hobby, and still do it to this day.
Well, walk us through that real quick, because like what would it take if someone was interested? So you've written about this on Hackaday as well. That's kind of how you started writing with Hackaday, I believe.
Yes.
But what does it take to make the simplest vacuum tube if someone was going to be interested in doing that?
Well, the hardest thing is glasswork, of course. Glasswork is an art. I don't pretend to be an expert at it. As a matter of fact, last night I was having great difficulty. It seemed like nothing I could do would work last night. So that's when you just shut everything off and go to bed.
Right.
But the basics are you need a hot emitter, which in most basic sense would be a tungsten, just plain tungsten. Typically small diameter. The typical diameters used in basic devices are anywhere from 1/1000th of an inch up to 10/1000ths of an inch. And that's run at incandescence, and it will provide electrons at that point, and then something to catch them. Generally speaking, nickel is used. It has a very, very low vaporization point, vaporization pressure at temperature, which is critical. Things in vacuum tend to sputter and evaporate. That's how mirrors are made, and carbon film resistors.
Go watch Krasnow making using his sputtering machine. He loves that thing. So
yeah, exactly. I look at that, and I tried it one time, but without proper technique and technology, all I did was make a mess. Did make some mirrors, but
yeah, right. But you're not going to be custom plating at like micron thicknesses and stuff like
that. No. My thickness control is it boiling yet? Okay, it's already over.
right. I probably should have turned that off about a minute ago. Yeah.
Yeah. So once again, I'm sure that's a whole career someone could dive into just doing that. But
how did you figure out? So you mentioned even Ronnie was like she had trouble sourcing stuff at a professional level. How did you figure out what you were going to start putting into a tube? Like sourcing. Did you just source like tube stock of glass, or like when you talk about nickel and tungsten and stuff like that, is it just sheets of tungsten and nickel?
Yeah, you can still get, for the most basic form, you can still get, and the most basic form of a tube is actually still in production. Look up a Bayard Alpert ionization gauge with a tungsten filament. And that is the most basic form of a tube you can really get, and they're used for measurement of vacuum. Pull up some pictures, and you'll see, basic construction techniques. But the basic raw materials are still available for simple tubes. When you want to start making things that were really usable, though, you have to remember those companies took 20 years of development and research, a lot of it done by Bell Labs, to get proper materials. And I'll give you an example. In a receiving type tube with an oxide cathode, nickel sleeved oxide cathode, an increase of 0.1% of manganese, which is a common additive to metals for foundries and rollers to make it work better. 0.1% of increase over other reduction materials can completely poison the tube and make it completely unusable. So, and you don't know that until after the thing is already done and a failure. So you're going to try to condense the works of Bell Labs, RCA, General Electric, and Federal Radio into one company of one person trying to chase all this stuff down. It's not going to happen.
There are some YouTube videos about making tubes at Bell Labs. I'm going to try and find them, but the just the tube manufacturing stuff. I mean, like they had like glass masters there and on site.
Yes,
multiples of these people. So.
Yeah, there's two videos I highly recommend people look at. Number one, if you're interested in glasswork, Philips has a video from the 30s. That's an excellent video of their glassworks at that time, and a lot of their stuff I didn't realize they were blowing. A lot of the movie and projector bulbs and stuff they were blowing by hand.
Yeah.
And then also the Mullard Tube Company there's a video from them in the late 50s, early 60s, and it shows very good at showing the entire thing beginning to end, from raw materials to a finished product out the door. So I recommend people watch that. And then there's other ones from American companies and things like that. So,
yeah, yep.
But those are the main ones. And there's a couple of individuals out there who have rudimentary products or rudimentary parts that they make, and they show you all the way. Ron Soyland's one of them. He goes by Glass Slinger on YouTube, and then there's some other people too. Dalibor Farnay in Czech Republic is manufacturing Nixie tubes, very nice Nixie tubes.
Oh, yeah.
We actually just sold him a piece of equipment. Oh gosh, we're almost turning an hour now. I'll hurry things up. We haven't even gotten to podcasting yet. I went ahead and started looking for customers to buy the business, and one group based in California came along and decided they didn't have much money. But they had all the intent in the world, and they actually wanted to buy the company as it was, less the real estate, and we're going to attempt to continue manufacturing products. So we thought, okay, fine. These people are the right type of crazy. So now they're actively engaged. Well, they wouldn't agree. They wouldn't disagree with me. Yep. They're currently actively engaged in trying to find a place to set up the facility and get a proper path to walk down, and we'll help them as much as we possibly can.
Yeah.
So that'll be further news down the road. Like I said, I myself have retained the ability here for a lot of the historical processes and things like that. I maintain the ability to continue doing those things because there's always firms who would go to MU and say, "Can you please help us with this problem? You're the only people that have the antiquated technology to do it with." So as far as that goes, the loss of technology and things, I've made sure that it wasn't going to be completely lost.
Yeah. So you mentioned podcasting. Let's jump to that. So obviously we're on a podcast now. What are you talking about?
Okay. Well, so like I said, it's split two different ways. When I got rid of the repair business, I maintain a few customers for studios because I enjoyed doing that sort of stuff. And somebody I knew was a producer down at the Adam Carolla podcast. And he had mentioned to me that they were going to be expanding their studio, and that there was actually something I probably shouldn't talk about, but they were going to be out of the picture pretty soon, and that they would no longer have anybody in-house with the ability to fit out that studio. So I said, okay, well, I'll go down and have a look. So I did, and I'd been a fan of Carolla's radio show and Man Show and all that stuff. So I already knew the guy. I knew what I was in for. So I went down there and started looking around, and they were building a nice little studio there. And I said, okay, yeah, I'll help. And in looking around, I noticed all these race cars in back, particularly Datsuns. And I'm myself and Datsun fan and a race car fan. Actually, the first vehicle I ever drove before go-karts or anything like that was my neighbor growing up had this little Formula Renault. It looked like a little mini F1 car. And him and a partner would go drive it at events, and I got to drive that thing around the block a few times, and that was it. I was hooked. So I said, well, geez, I enjoy doing this too. So I kind of made a deal at that time. Well, I'll charge you just basically my materials and all that, and a little bit of travel for doing this, and don't throw me out when you go racing, So we did that, and ever since then, I've been maintaining and expanding their studios down there, and of course, Corolla Digital, as it is now, is the home to the most listened to podcasts on earth, the Adam Carolla Show, the Dr. Drew Show. All of those shows are consistently the highest listened to podcasts in their groupings and their rankings. So that's kind of nice. And a lot of the people there, all of the producers down there, shout out to Chris Loxamana, Mike Dawson, Gary Smith, and Matt Fondelier, who really runs the whole office, runs the operation there. Those guys are I consider them good friends, and even if everything else went away, I'd still continue to be friends with those guys for a very long time. So, but that is a whole interesting little world of it. He does not consider himself really a part of Hollywood, which I would say is reasonably accurate. But my gosh, the people who come through that door are interesting people.
Yeah.
Been all over with them to live shows, twice to Europe, and it's I like to joke it's my getting away from actual responsibility, because at actual work, where of all this stuff I do, I actually am a real product manager every day.
Right.
That's where I start getting nervous. Parts availability, keeping the business going, it's getting harder and harder every day. And that's yes. Finally, actual modern electronics I will talk about.
Okay, all right.
Yeah.
I mean, that's good. I mean, like, this shows like I think a lot of people can relate to the fact that, like, electronics is your job, but it's also your hobby, and obviously it led to some side gigs and some obviously a lot of interesting people, like you mentioned. But sometimes you still have to go back and figure out where the hell you're going to get the next capacitor, because holy crap, which I think is one of the, I think for like a couple months now, I've been getting, 2 a.m. texts from you. They're like, what the hell? China, I can't get 62 weeks on a lead time. What's going on here?
Yeah, that's that little window into my life. Yeah. Being a small manufacturer, we have to work through distributors, and we order such a weird eclectic mixture of stuff that it's I always joke with our purchasing guy who's really my brother-in-law. One day I'm just going to redo everything just to be parts out of the DigiKey catalog, and we're just going to order everything from them. And 2 of my vendors probably just hit the ground in a panic, it is to the point now where I've put out word to everybody, all of the vendors. Some of them don't listen, but we will only be now accepting name brand, particularly passives, because my gosh, you should see the junk that some of the lower tier distributors are digging up and shipping over here.
Oh yeah,
particularly in surface mount components, but always has been in capacitors.
Well, how do you tell about the quality? Is it you're seeing failures after assembly and that kind of thing, or is it you're actually doing incoming inspection?
Well, we actually we do both. First of all, if it gets in, and we're small enough to where I can still physically every day go back there to all the stuff coming in the door and look it over. If I catch real low quality stuff, I'll just throw it in a box. Yeah, send it back. But we actually just had a rash of ceramic disc 22 picofarad capacitors that something went wrong in their processing, and they were hygroscopic, so they were sucking up moisture right out of the air, and then when we'd go to solder them, they'd spall. Yeah, they'd spall. Well, they wouldn't pop; they'd spall, and that was causing all sorts of problems.
What does spall mean? I don't actually know that term.
The surface started crumbling off.
Oh wow! Did you see that picture that Dave Jones had posted, where it was just some ceramic caps are just a surface mount cap that are with two leads attached and then encapsulated in like a fake thing.
Oh yeah, yeah. Actually, that has legitimate beginnings.
Oh really? Okay.
Yeah. The monolithic timing capacitors, the little yellow epoxy dip, they look like micro tantalums. Those, if you crack those open, those are generally speaking a MLCC capacitor in there with leads attached, dipped in epoxy. And believe it or not, that's actually what I changed the specification to on all of our timing caps recently.
Oh, okay, interesting.
And yeah, that is actually. I mean, the picture was not legitimate. I mean, well, it was. That was not a legitimate thing, but the idea of that has been around for a long time, and that's what the monolithic, low value caps are.
Got it.
So, and that comes from how they did the wire bonding on the disc caps, which they dip it in basically a cement. That yellowy, orangey stuff that they are. That's basically a cement that's supposed to be varnished over to prevent moisture from getting in, but they didn't get that message on this batch, evidently.
Right. Interesting.
So that and electrolytic, your bulk electrolytic caps, they are the heart of your product, especially if you're doing anything with any sizable amount of power. Just because a manufacturer has a spec on them doesn't necessarily mean that's what they are. And I periodically take caps. Our most used is a 25 volt, 1,000 microfarad bulk, through hole cap that we use on pretty much everything. And I'll run. I'll do my own ESR tests on them and my own forming tests on them. And oh boy, there is a difference between brand. You really do want to spend those extra cents on that Nishikon or Rubicon or something like that. And that's for 2 years has been an issue for me because of the parts availability. You kind of get what you get. It drives our company controller nuts. Because one month I'll order them from whatever Future Electronics or something like that, and then the next month I'll see they'll pop up at Mauser. They'll have 5,000 of them, and I'll grab those.
Bargain shopper,
Desperation.
Go to the flea market one day, and you're like, yeah, I got these off the back of a truck.
No. Well, that's what I suspect some of our distributors are doing, buying stuff Shenzhen market in China and sending it to us.
True,
well. If they're going to do that there, I'll just do that here, and at least I'll know what brand they are.
At least you can inspect them as you buy them instead of after they get shipped.
Yeah. But part of my biggest problem now is I'm physically having to do that. It's I'm trying to design a whole different raft of new products, and now. The biggest thing, one of the biggest growing market segments right now is IoT and agriculture.
Sure. Yeah. Smart ag.
And we have a number of customers who are telling us they're getting approached by these, 1-2 man shops, to do automated systems for them, and they can't trust them.
Yeah.
They need to know they're going to have support for this 10, 15 years down the road.
Right.
And
well, good luck with that.
And they can't, well, yeah. And they know they can get that from us. So they looked at that. That's really the biggest impediment for all of these small companies doing this stuff is they don't have the decades of trust built up between them.
That's interesting.
Farmers are not a trusting lot.
Yeah, I was going to say. So what is it like selling to farmers? I mean, are you selling directly? I mean, you're selling white label still to like, I guess, an OEM to the to like a integrator or something like that?
Yeah, we do that. But most of the customers have now come around to the idea that it's easier for us to have our name on the box because when the customer has a problem, they call us directly and they don't have to have their own service department.
Yep. Right.
So, and we're perfectly fine with that. Yeah. But we sell through distributors, but the distributors are a very close person. It's still a distributor. The farmer's driving into their shop, picking up things.
Got it. Yep.
So I say distributor, but it's it's a little more personal.
Sure.
Than that. And then we have a very open policy, and all of the distributors know it, that the customer anytime is allowed to call us or bring the product in and have us review it for him. We will always bill them back through said distributor, but we have a very open door policy on service.
There's no like firewall or like you have to ship it in, that kind of thing.
None. None. Very often the customer will drive in directly to us. They'll hand us their one for repair. We'll hand them a loaner. We'll have them sign a packing slip. We'll say, well, what's your distributor you go through? Because they've got discounts set up with their own distributors that they like using. Yeah. Who do you use? We'll find out that information. We'll give them a quick call. So-and-so's in here. They brought this. We're sending them out with the loaner. And then off and running we are. The customer remains up and running because in ag, in the middle of summer, if you're irrigating and you only have a few days access to water, because that's how they generally limit water delivery here. You irrigate the first week of the month, you irrigate the second week of the month, or you only can irrigate between these 2 hours of the day.
Yep. You better do it or else critical. You start losing money at that point, right? Because your crops die.
Oh yeah. You can have $10 million of crops go upside down in a few days.
Jesus.
If you get a spike 114 degrees, and you can't put water down, you're just calling your insurance company and saying, sorry guys,
Yep.
That's real stuff.
Yeah.
You want to talk about nightmares. I've talked to citrus growers out here that were, it gets down 26, 27 degrees. They have to irrigate. It changes the dew point out in the field and raises the temperature a little bit. And if they can't do that, they can see an entire year's worth of citrus on 5,000 acres turn to useless in minutes.
Wow.
So, these things have people a lot of times pile on big agriculture, but with big agriculture comes big headaches and big worries. Yeah. And a lot of that big agriculture is controlled by small growers. So they're the ones who suffer. We don't let that happen. My cell phone is on 24 hours a day, and I do get those calls sometimes in the middle of the night. You're flooding the your controller's flooding the highway or something like that.
That's a great call.
So Well, I've gotten that call a few times.
Yeah.
So
then what about the shift to like IoT and smart based stuff? Like is that getting pushed at the high level from the big companies that are like that are pushing down on their small growers, or is it small growers being like, look, I just need to know how this goes? Like what are the pushbacks that you're getting?
Yeah, it mostly comes from the scenario is grandpa passes away and the grandson takes over the ranch, and grandson also has another job in the city. So he can't afford to be out there on the ranch all day seeing what needs to be done. He wants to be able to see remotely what's going on. Big growers have whole departments full of people who take care of that stuff, and they're generally speaking not going to trust their tens of millions of dollars of crops to a $300 irrigation controller that uses an iPhone app. They're not going to do that. They may want that for just informational purposes, but they're not going to want that. Similarly, the small grower, he doesn't have enough people to run around and do that, so he may want to see from his home what's going on. It's kind of a middle out. Oh gosh, Silicon Valley.
Yeah, right.
It's middle out at this point. Whereas the people at the high end either already have their own proprietary systems or just simply don't need it. And then the smallest of the small guys, they probably live on their ranch and look at it every day and don't care.
Got it. Okay.
I've often joked our biggest seller would just simply be a box that just says, water and not water, with a big knife switch that throws sparks when the sparks are critical. Yeah. Throws sparks when they throw
sparks
it.
Sparks work great with water too.
Yeah. Oh, fantastic.
Yeah,
right. But no, we're even though most of our products are fairly old in design, we are moving along, and we're moving into IoT. We had an entire system based off of just SMS a few years ago up and running. But after talking with a number of different carriers, finally getting a hold of people high up who could answer questions, the general consensus with all of them was don't do that. Get on the internet. Don't rely on any of the other services. And that's when we decided, and not to spill too much about what we're doing, but it's what a lot of other IoT people do to get low bandwidth is get us on the internet, which means we can use any modality, be it Wi-Fi, Ethernet or a cell modem. Get us on the internet, and we'll just start publishing MQTT things. Everything will go that way, and that's that. that's no secret. That's what most people are going to have to do to fit in, to get the costs down on the service. The carriers want everything to just simply be internet traffic.
Mm-hmm.
They don't want anything else. They don't want to handle voice. They don't want to handle
right, of course,
SMS.
Of course.
They don't want to handle those other things. So, and that's actually where I started. That's really when I started calling you in the middle of the night. Was while you were working at Hologram.
Yep.
So, because that's still a little plug for them. That still is the easiest way to just simply get me on the internet.
Right. Yeah, well, that's good. That's good. I mean, I think that's pretty relevant to people that are listening too. Like people, like maybe not relevant that they're looking specifically at these problems, but I think a lot of people are, maybe looking for business types and stuff like that. It seems like the B2B, I would still call this B2B market, even though you're selling to individuals probably who are small growers. B2B market and doing like service-based things that are including hardware like this, it seems like if you can get the trust, like you mentioned, there's a lot of need. It's a practical use for Internet of Things type stuff. And from that perspective, it's interesting. Now it's interesting to me that you, as a maker of these things, you said you're actually having trouble finding people to work on it, though. To work on hardware. So let's talk about that real quick.
Yes, we're like I said, we've had the same main engineer since the 80s doing our hardware. We in 1998 or 99 hired an in-house engineer to do firmware and hardware as well. And those between those two were pretty busy, but they're both gentlemen kind of towards the end of their careers, and neither one of them has really ever been a production engineer. They're design engineers, not really production engineers. And really, to be perfectly honest, I need somebody to help take over part of my job, because here I am running around taking care of day-to-day things, answering assemblers' questions, doing part sourcing, working up new part numbers, assembly tools and things like that. And then I've got to turn around and handle the business end of it, the product management side of things. And it's really too much for one person. We do have a consultant that we use to do software, and he's a relatively younger engineer, and he's I like to refer to him, he's the wall I throw things over. anything that has to do with high level or high level embedded, I throw over the wall now to him, because he's our wizard. He's the one who can take the thing, magically find a library somewhere out there and get the thing working in 45 minutes. So so we have one of those.
Right, but you had mentioned too that like some of it is just limited by location, that you guys, you're in Fresno, but it's not necessarily a tech center, and then you kind of get what you get.
I need a production engineer, production and quality control engineer. If I was in the Bay Area, I could stand outside with a sandwich board, and within the first 100 cars driving by, probably have someone pull over inquiring about the job.
I mean, if you offered enough, yeah.
yeah. Well, we're. I'll put it this way: in our entire history, we have never had a single person quit. So that tells you what sort of working environment we have.
Yeah, right.
Nor have we ever actually had to fire a person.
That's good.
One time we did have to lay a couple of people off just for slowdown, but that's beyond our control, really. We are a family business, but we treat all of our people like family.
Yeah.
So.
Well, and I think that this is something that and this is kind of how we started talking yesterday about this too. But it's just like that is not as basically as companies start to age and stuff like that, they're either the methods have to change or the people have to change. You have to grow the company in a certain way, replacing engineers who decide to retire. I've always said, I think there's going to be, after the 2008 crash, I thought there was a bunch of engineers who were kind of hanging on just because they weren't able to retire because their portfolios crashed. Now portfolios are back up. I think, this is stock market stuff, but I think portfolios are back up. The age is right, stuff like that. I think that a lot of boomer engineers, who are graybeards, who are going to just start to be like, yeah, well, I'm done. I'm not sure
Yeah.
there's, I think there's going to be a lot of jobs that are open, specifically in places like you're talking about that are like more remote,
Yeah.
more obscure, might not know about it.
Exactly. Yeah. Well, I'll give you an example. I can find software developers. They're out there. I can find web app developers.
Right.
That's out there. But I need somebody who can walk around that shop and kind of just, like I said, sniff out the problem.
Yeah.
No,
Right.
the plating on these boards doesn't look quite right.
Right.
Let's investigate this.
Mm-hmm.
Or that assembler over there, I've noticed they're, when they're putting those screws in, I can hear they're going to a different torque.
Mm-hmm. You're right.
What's going on over there?
Right.
That's the sort of experience that people really need. And you only get that by doing. You only get that by throwing yourself headlong into hardware projects and experiencing what goes on. The most attractive thing about an engineer is someone who knows how to get something out the door.
Yeah.
And get it out the door right. You can go into an endless development cycle, and we have our own versions of endless development cycles. Lord knows we have our own versions of endless development cycles, but we still have to get the things out the door, get the customer happy, have them have something that they know is going to be reliable. We'll gladly sacrifice a feature for reliability. We do that all the time. That's actually one of my biggest parts of being a product manager,
Right.
is determining
Say no. Right.
Yeah.
Make that next switch product.
Yep. You get a sense after you do enough of your own development and see other people doing it to know, okay, here's how much effort this is going to take to debug and verify this particular feature. Here's the potential downsides to it. What you may think is that, oh, this is great. Well, it may be great, but it may have some downsides, and we may spend the next 18 months trying to figure out how to do it right. We can't afford that. That's the sort of experience you really need to get, and you only get that by doing. And there will always be need for hardware engineers, always. But they're just the people. It's not the attractive thing. It's not the whiz bang anymore. Designing a board. Oh, don't even get me started on the EDA problems we're having. Well, I'll give you a quick one with that. A lot of our stuff originally in the 80s was done in Highwire. Then in-house, we switched to, we tried Dip Trace for a while. None of us liked that. Then we went to Eagle. We used that for a number of years. Then when Eagle decided they were going to change their thing to an online subscription base, we, like everybody else, freaked out. And just at that time, Altium came around to everybody, and they cut the price of Altium basically in half, looking to pick up rebound people who were reeling from losing Altium, or losing their version of Eagle, which from the inside view, Eagle was already kind of not supporting their product particularly well. I had some interesting phone calls with them where,
like when you're calling Germany,
it was the equivalent. Yeah, well, it was the equivalent of them picking up the phone, screaming, "What do you want from me?" and hanging the phone up. It was the engineering equivalent of that. Right. So we went ahead and got a seat of Altium, and we're using it, and it's good, it's nice. But my gosh, are they, as far as a piece of software you own, they are so restrictive. Where initially they told us, a number of different things. Well, things changed. They've changed their company policies, and now we're getting text messages. Because how we handle internet at our shop, we have a number of IP addresses, and when they see it bounce around, they get nervous.
If only there was a solution that was open source and free. Geez, Charles, I don't know, man.
We just now started our new product, a new product and a new product tree in KiCad.
Hey, all right.
So at our shop, Jason has watched many of your videos, and I told him if he wants, I don't think he needs it at this point, but you could always use it. I said, if you want to buy a course in contextual electronics, just let me know. I'll do it for you.
Give my number. Give my number. It's fine. Yeah. That's great.
Well,
so if,
hey, it's a tax write-off.
Yeah,
so.
right. So if people are listening listening and they're interested, maybe giving you a shout if they're in the Fresno area, what's your how should they get in contact with you?
If you're in the Fresno area and you're looking for an engineering job, or you're willing to move to the Fresno area, go ahead and contact me. My email is brokenspeaker7@gmail.com. And go ahead and let me know, and we'll see. It's not an easy work, but you'll be doing everything from literal hardware engineering of our metal and plastic enclosures to testing and quality control and everything in between. If I have to explain to you, however, what a differential long tail pair is, then that would be a good first step. That's usually my one that I catch most new engineers on is design me a differential input to do this, and their eyes roll back in their head and they start going to Wikipedia, and it's like, okay, I'm sorry, we're done here.
So I thought you told me before it's actually brokenspeaker9@gmail.com. Is that right?
Yes, Broken Speaker 9. I'm sorry. I roll it forward every now and then, depending on what I'm working on.
Got it. Yep.
So, seven was the one for the liquidation. Burner addresses are a thing. Yeah.
Cool. Okay. Well, Charles, thanks so much.
But anyways,
thanks so much for being on the show and talking about all. I mean, obviously a lot of interesting past, and good luck with the family business too. I think it's really interesting to hear that stuff.
Yeah. With hindsight, I kind of wish I could have picked one thing and not jump around from thing to thing to kind of focus on. Might have been a little more interesting for people, but hey, this is how our lives are built. Many unseemingly or seemingly unrelated things connected to each other that lead you down your own weird little path, and we didn't even get into Neoden or any of the modern assembly stuff. But that could be a whole show unto itself. Low rent. Most people will say, "Why do you bother with that? You're a real company. Why don't you just rent more time on someone else's machine or buy a real machine?" Well, at a certain point, we had to get our feet wet. We only do things in batches of 50 or 100 at a time. And it just simply happened to fit us that we could fit all of our products on one set of feeders. And I eventually did get the thing to work, so it does work.
Right.
But it's not a finished tool.
Right.
It's definitely you got to stay on top of it, and each time you fire it back up, you're learning a new quirk. So that's about as far as I'll get with that. But I would certainly not accept other customers' assembly work on it, only for our own stuff, so we could set it up and leave it alone.
Awesome. Well, we'll have to have you back on to talk more about future assembly processes, and hopefully we'll find you some people here. And I'm glad that our paths have crossed over the years too. It's been good.
Same here. Same here. It's sometimes I like to imagine a more carefree world where I could go work on my own projects and have fun and write articles and do all these interesting things. But no, I can't.
Awesome. Yeah,
I'm here.
Well, that's good. That's good.
Well, thank you, sir.
Yeah, thank you much. All right. Well, we'll talk to you soon.
Okay. Bye-bye.